During the engineering phase of an industrial complex, thousands of piping drawings are generated to provide the detailed information needed for construction. Let's explore the many source documents that a piping engineer must use. The project requirements and the various engineering documents that will serve as the foundation for the piping team to interpret and convert them into construction drawings and specifications, enabling the fabrication of the industrial complex. Out of all the documents produced by different disciplines, we'll focus on a few that are particularly important as starting information for the design of piping systems. For example, project basis and criteria, piping specifications and criteria, PFD, process flow diagram, and P&ID, piping and instrumentation diagram, line list, equipment list, datasheets, mechanical equipment drawings, foundation, structural, and area classification drawings, etc. Let's look at them in a bit more detail. Design bases include the criteria, assumptions, and limitations used for detailed engineering and the final product design. It essentially refers to a set of conditions, requirements, project needs, and performance criteria, including legal requirements and design codes. Different organizations follow various formats depending on the industry. It could be a set of documents or a single extensive document that covers all project aspects, from the initiation phase to installation and commissioning. The design basis document begins during the conceptualization phase and is updated as the project progresses with all relevant information. The last 4 points are highlighted in red because they are especially important for the design of the piping system. Another type of starting information for the design of the piping system is the piping design criteria document. This contains the physical attributes, loads and service conditions, environmental factors, and material-related factors that must be considered in the detailed design of the system. Physical attributes are the parameters that govern the size and dimensional limits of the piping system. Dimensional standards have been established for most piping components, such as fittings, flanges, and valves, as well as for the diameter and wall thickness of pipes manufactured to standard specifications. Load conditions are forces, moments, changes in pressure or temperature, or any other parameter that affects the stress state of the piping system. Examples of load conditions might include internal pressure, the weight of the piping system itself, wind conditions, etc. We refer to service conditions when analyzing loads that occur simultaneously, so the piping system must be designed to withstand their combined effects. The so-called environmental factors are operating conditions that can result in progressive physical or chemical deterioration of the piping system, which may ultimately lead to a rupture of the pressure limit or a major structural failure. Examples of these factors can include corrosion, erosion, or physical damage. Material-related factors refer to the specific chemical, metallurgical, and physical properties of the material, components of a piping system that can ultimately determine their suitability and adequacy for a particular service. Among the most relevant documentation used for piping design are process diagrams. These are graphical representations that describe the stages, operations, equipment, and flows involved in an industrial process. These diagrams illustrate how products are transformed, showing the steps of the process, inputs, intermediate and final products, as well as the flow paths for materials and energy. There are three main types of process diagrams: block flow diagrams, BFDs, process flow diagrams, PFDs, and piping and instrumentation diagrams, PNIDs. Block flow diagrams aim to describe what is the process. Process flow diagrams describe what the process does, and piping and instrumentation diagrams include much more detail explaining how the process is performed. The difference between the various types of diagrams lies in the information each of these documents can provide throughout the life cycle of a project, which ranges from visualizing the process to the implementation and operation phases. The BFD is a type of diagram that groups equipment into units, showing them all as a single block and presenting the interrelationship between each of these units. It displays the flows exchanged between them and how those flows change throughout the process. In a PFD, the units are expanded, showing the equipment that makes up each one, but without much detail. Only the main equipment and the most important control loops are shown. Finally, PNIDs are key documents in any process plant. They describe all the steps of a plant's process. Essentially, it's a process plant on paper. In a PNID, the pipes, process equipment, and control systems are shown schematically using a set of predefined symbols with no scale and no geographical orientation. The process discipline also generates an initial version of two key documents for the piping division: the line list and the equipment list. The line list enumerates each of the pipes identified from start to finish. It includes information on various process properties such as fluid, design temperature and pressure, pipe size and class, heat treatment, routing requirements, painting, and insulation requirements, as well as a unique reference number. The equipment list contains all the equipment primarily static and rotating, though furnaces, ejectors, etc. are also listed. The list is generally divided by type of equipment: pumps, vessels, towers, heat exchangers, etc. The equipment list includes a reference to the corresponding equipment datasheet, another key document that allows the piping discipline to carry out this work. The datasheet contains the structural and operational conditions of the equipment. Also linked to the datasheets are the mechanical equipment drawings, which are of great importance to the piping designer as they indicate, for example, the dimensions and location of the nozzle connections. The civil and structural engineering discipline provides foundation drawings which show the dimensions and shape of the foundations to support the structural steel or the major equipment. Also provides steel structure drawings which describe the frames and steel parts that support the mechanical equipment and pipes. In the example, you can see a metal frame that will support part of the main piping of the plant. As the last main input for the design of piping systems, we'll mention the area classification plan. Its purpose is to identify the areas of a plant that present a higher explosion risk due to the potential presence of flammable atmospheres. The boundaries of these areas are outlined to ensure that electrical and electronic installations comply with standards for installations in hazardous areas. Some engineering companies assign the task of developing this plan to the electrical discipline. However, since the process conditions are key to developing this document, it is generally considered the document issued by the process department.